Good morning, everyone. My name is Pratap Gaurav Upadhyay, and I am from ECE department. Today, I will be talking about rectifiers. It is an application of diodes, and this topic is from the Unit 1 of Fundamentals of Electronics Engineering, BEC 101. Rectifiers. What are rectifiers? They are just the application of diodes, and rectifiers are nowadays widely used because we are now dealing in DC sources and we always have AC in our surrounding. So if I want to convert AC into DC, I have to use rectifier. And in this, what happens? The rectifier is an electrical device that converts the incoming AC from a transformer or other AC power source to form to some form of pulsating DC or unidirectional DC supply. That is, it takes current that flows alternatively in both directions and modifies it so that the output current flows only in one direction. What happens? A rectifier is basically made up of some diodes, one, two, or four diodes, and this diode will convert my pulsating or alternating AC current into a pulsating DC output. This what we'll see. Now, what is happening here? This is what the block diagram of rectifier is. In this, we will be using a step down transformer so that my high voltage AC can be converted to low voltage AC. Then this reduced voltage AC signal is transformed to or processed further to rectifying circuit, and this rectifying circuit consists of diode, and in this circuit my alternating AC current, it will convert to a pulsating DC output. Now this pulsating DC output is containing some AC component as well as DC component. We use filter circuit to reduce the AC component, and after the filter circuit we use regulator circuit which is used to tune the output, and we get a near constant DC supply. Using this whole block diagram, we can produce AC to DC. Now, there are two types of rectifiers that we'll talk about. First is half wave rectifier. It is a simple type of rectifier made with single diode which is connected in series with the load. We can see that for the positive half of the cycle, if we see for the positive half of the input signal, this diode will be forward bias, and for the negative half of the input signal, this diode will be reverse bias. So for the positive half, it will provide the output, and for the negative half, it will not provide the output. Output will be zero, and we are getting half wave, and that is why it is known as half wave rectifier. We can, and the advantage of half wave rectifier is that it is very simple and it is very cheap, but the problem with the half wave rectifier is that the ripple is large and the power consumption is huge because only half of the signal is being out getting it output. And to overcome this, we use full wave rectifier, and there are two types: full wave center tapped, or we have bridge rectifier. So first we'll talk about the center tapped rectifier. This rectifier uses two diodes and a transformer with center tapped secondary winding. During the positive half, see, this is what is the full wave rectifier is. During the positive half of the cycle, if we see, then we will see diode D1 is only getting forward biased and will get the positive half at the output. During the negative half of the cycle, we will see D2 is getting forward bias and D1 is reverse bias. So from the D2 we'll get the negative half, but my polarity of the output will be same, and for both the cycle, positive and negative, we will get the output, and we are getting both the wave. That is why it is known as full wave, and same process will be followed. It will be passed through filter and then will be regulated and we'll get the DC constant supply voltage. After this, we go for bridge rectifier. Now, in case of full wave rectifier, we are using a center tapped transformer, and it has a disadvantage that whatever secondary voltage we'll be receiving, we have to divide that into two equal half, and that's why we go for bridge rectifier. Bridge rectifier will be using whole secondary voltage. There is no need to divide them. Only thing is that in the bridge rectifier we use four different diodes, In this, we can see that we are using four different diodes, and depending upon the cycle, two diodes will be forward bias and two will be reverse bias. For the positive half cycle, we will see that D1 and D3 will be forward bias, D2, D4 will be reverse bias. For the negative half cycle, D3 and D2 and D4 will be forward bias, D1 and D3 will be reverse bias. See here we can see that for the positive half cycle we are getting the output like this, and for the negative half we are getting the output like this, and as a whole we'll get the output for both the cycle. And this is what the advantage is, that we are getting whole secondary voltage at the output, and it gives higher rectification efficiency, it gives higher output voltage, higher output power, and it is not requiring any center tapped transformer. This is the advantage of bridge rectifier. Thank you.